Hello everyone, MK's here. Welcome to this session on vectors. Whether you are preparing for CBSE, JEE or ISC, understanding vector is crucial. Vectors are fundamental in physics and play a significant role in mechanics and electromagnetism. Not only mechanics or electromagnetism, all related topics are dominated by the idea of concept of vectors. Let's dive into why vectors are so important and how they help us understand the physical world. What are vectors? First, let's define what a vector is. You know scalar and vector quantities in physics: velocity, acceleration, force, all these are vector quantities. A vector is a quantity that has both magnitude and direction. Unlike scalars, which only have magnitude, vectors help us describe quantities that inherently involve direction, such as force, velocity, and displacement. You know, speed is a scalar quantity, velocity is a vector quantity. Why? Because it includes both the speed and the direction of motion. Mechanics. Let me tell you again. In mechanics, vectors are indispensable. When we study motion, forces, or momentum, we use vectors to accurately describe these quantities. For instance, when analyzing the trajectory of a projectile, already some of you have finished it before, we break down into motion into horizontal and vertical components using vectors. Newton's second law, that force equal to mass into acceleration, there also in some problem we need to break force into its components. Understanding how to work with these vectors helps us predict how objects move under various forces. In electromagnetism, vectors are equally important. Electric and magnetic fields are vector fields, meaning they have a magnitude and a direction at every point in space. One of the great strengths of vector is its ability to simplify complex problems. By breaking down vectors into its components, we can analyze each direction independently. This method is particularly useful in problem solving. For instance, in projectile motion, we treat horizontal and vertical component separately, making the problem more manageable. To sum up, vectors are not just mathematical constructs. They are powerful tools that helps us understand and describe the physical world with precision. As we move forward in this session, we'll explore various vectors of operations. You will learn how to add, subtract, multiply vectors and apply these concepts to solve problems in mechanics and electromagnetism in future classes. So this class is important. This is meant for understanding vector quantities. Vector quantities in 2D and vector quantities in 3D. Stay tuned and let's get started with vectors. So in this chapter, Motion in Plane, chapter 4, in class 11 syllabus, in lesson 1 we will be discussing vector. Lesson 2 will be motion in plane. Motion in space will not give much stress now, but we will do all these in future. To discuss motion in plane, the concept of vector is very important. Sometimes it is called by some of us, vector is the gateway of mechanics. I mean, whole of physics. The concept of vector is so important, some topic you cannot understand if you don't know vectors properly. So let us learn what is a vector here. First, we'll define a vector as a directed line segment. First session we'll be discussing vector as a mathematical object, but gradually you'll be able to understand how the concepts are beautifully applied in physics, in motion in 2D. Motion in 1D, we will not apply the concept of vector. Just as I have told you in the previous session, vector concept is not required there. But here, we need the concept of vector to discuss the motion of an object in 2D. We will be defining in terms of 2D first, then I will show you how to define vector in 3D. A vector, the very first definition will be, it is a directed line segment. OA is a vector, A is the tip, O is the tail. Arrow you can put anywhere in between O and A, it will be a vector quantity. This is different from scalar quantity. If I say OA is a line segment, then its length say 5 cm. OA has length 5 cm only. But if it is a vector, then we need to specify two things. Its magnitude, length, as well as the direction. So the first definition of vector will be, it is a directed line segment. A vector is a directed line segment. O is the OA equal to A, we are referring this one as a vector. We will be knowing O as the tail and A is the tip of the vector. Or sometimes O is referred as the origin. You can say the point O as origin also. Now, this vector has magnitude, length and direction. This vector directed from, it is directed from O to A. Length of the vector we will write as its magnitude. Length of vector A is equal to modulus of vector A. This we can simply write as A only. Okay. So vector without arrow will represent the length, or we write modulus. This symbol stands for modulus. This is length. This is actually the straight line distance between the tail and the tip of the vector. Now, these vectors may start from the same point. Based on that, we will be referring vectors as co-initial vectors. Okay. Let us know just a few types of vectors. We are going to define co-initial vectors. Co-initial vectors start from the same point. They are starting from the same point A. These are two vectors I have taken, OA and OB. Suppose this one is A, this one is B. We can take another vector also. OC is also a vector. This we can refer as C vector. So these three vectors A, B and C, they will be referred as co-initial vectors. So A, B and C will be referring as co-initial vectors. Because they are starting from the same origin, same starting point, same tail, whatever you see. They are co-initial vectors. Vector can be slid parallel to itself. Let me define first what are parallel vectors. For parallel vectors, this is vector A and this is vector B. These two vectors are parallel vectors. Why? Because they have the same direction. So two vectors A and B are parallel. We'll be simply writing A parallel to B if they have the same direction. Implies A and B have the same direction. Okay. One of the most important property of vector is that in this plane it can be slid parallel to itself. An important property of vector. A vector can be slid parallel to itself. This you never forget. So actually in case of vector, there is no difference between collinearity and parallelism. So this vector, see, we can translate, we can take on this vector B. If I am taking the vector A here, then these two vectors, if I have taken vector say AB, that AB we can slid here, coming to new point, let it be A dash B dashed. Previously the vector B was in figure AB equal to A and CD equal to B. We slid the vector AB parallel to itself. It will fall on the vector CD. Now A dash B dashed is its position. This A dash B dashed and AB, they have the same direction, they have the same magnitude. So actually I have taken vector A on the vector B, they become collinear now. So parallelism in case of vector, parallel vectors implies vectors are collinear also. Okay, those parallel vectors are collinear vectors also. They can be slid parallel to them. It's a very important concept. When you are going to add two or forces lying at different points in the plane, you can make them collinear. Okay, how? Suppose a vector lying here, a vector A lying here. This is a force vector. Another vector lying there. This is another vector, force vector F2. And to add them, how to add them, that I will definitely explain. You can slid this one parallel to itself. This one you can slid parallel to itself. How to slid? Let me explain. Just a minute. I will slid this one parallel to itself. It goes there now. They become co-initial now. Now our addition will be easier. Clear? So a vector, remember, can be slid parallel to itself, and this will help us to add two vectors vectorially. Before doing that, let us know unit vector. Magnitude of vector I told you. What is a unit vector? And before we do unit vector, we need to learn scalar multiplication. A vector can be multiplied scalarly. Based on that, we'll define scalar multiplication. Scalar multiplication. There is a vector. Just I give you example, it will be easier for you to understand. This vector is a vector. Somebody has told you to draw 2a vector in this plane only. So you will magnify it in the same direction and length become twice, then it becomes 2a vector. If you are supposed to draw a by 2 vector, keep the direction same only, just magnitude half of it. This will give you a by 2 vector. You can draw on the same line also. This is the vector a by 2. So this is scalar multiplication. Vector can be multiplied by a scalar to get a vector in the same direction. Maybe in opposite direction also, that I will explain when we know negative of a vector. But before that I tell you, vector can be multiplied in this direction indefinitely. I mean, if magnitude given 10a also you can draw. We just magnified it 10 times in that direction. A by 2, a by 3, a by 10, all those can be defined here. Now, suppose the vector, any vector has some magnitude given. I am taking here the vector whose magnitude is say 5 unit. This is the vector of magnitude 5 unit. 1, 2, 3, 4, 5 unit. This vector I am writing A, and the vector I am naming as O2A. O2A vector is A, left. OA equal to A. How do I write its magnitude? Mod A. Mod A, as I told you, it is 5 unit. You simply write 5. Mod A equal to 5. What will happen if we draw a vector whose magnitude 1 in the same direction? This is the vector whose magnitude is 1 in the direction of the vector A. How will I write this vector? This vector, suppose I am denoting by this symbol A hat or A cap. A cap going to be A divided by 5. You agree with me? Because you have taken a length of OA 5 unit. We are dividing. This looks a bit inclined. No, in the same direction only. Same direction as it is. This is A hat, A by 5. These two vectors have same direction, but its magnitude is 1/5 the magnitude of this. This is called unit vector. For any vector, you can define unit vector in that direction. Let me tell you the definition first. Unit vector, this may be of 10 unit, then you need to divide by 10. So, unit vector A hat or A cap along A is defined as A hat equal to A divided by mod A. Clear? Unit vector A hat along A is defined as A cap equal to A divided by mod A. That's why we have written this. A cap equal to A divided by 5. But in general, definition will be like this. Question arises, why I am so interested to share the concept of unit vector with you. This is a mathematical presentation. I told you the first session will be the mathematical presentation. So everything we are defining mathematically here first. Imagine for this vector, a vector given here, somebody has told you to represent the vector of 10 unit in the direction of E. Then what we will do? A vector, for this example, a vector of magnitude 10 units along A. Now, by now we will write B equal to 10 into A hat. Why 10 into A hat? Because A hat is in the direction of the vector A. So if I multiply this by 10, A hat only if we magnify 10 times in this direction, 10 times, you just magnify, you will be getting the vector 10A. It's like that. So unit vector assigns direction. It will tell you the direction in the along a particular direction you have specified. When you are taking coordinate axis, we'll be using standard unit vectors over there. For this coordinate axis, x and y, unit vector will be I cap and j cap respectively. Okay, these are unit vectors along coordinate axis I cap and j cap. So if I want to write any vector of magnitude 5 unit along x-axis, we can write this manner. A vector of magnitude 20 units. 20 units along x-axis we'll write as the vector equal to 20 into I cap. A vector of magnitude say 15 units along y-axis. How do you write that? It will be C vector equal to 15 into j cap. It's like this. Concept of unit vector is important this way. Any vector in a particular direction can be written if we know unit vector in that direction. Simply, we will do this multiplication, scalar multiplication, multiply it by 20 units. Clear? Now we are writing the case of parallel vectors. For two parallel vectors, what will be the general relation between two vectors? Suppose there are two vectors. This vector is P and this one is Q. For two parallel vectors, P and Q, we can write P vector is equal to M into Q vector, where M is a scalar. Okay. So why? How to prove that? You can write P vector equal to M into Q vector. Very easy. Suppose in this direction unit vector is known. Unit vector is R cap. Then P vector you can write what manner? P will be equal to, suppose modulus of P is x unit. Let mod P equal to x, mod Q equal to y. Then P vector will be what? X into R cap. Q vector will be what? Y into R cap. Clear? So if you just go on dividing that p by q, although vector division I don't want to do, but we can relate these two quantities, that p by, just you write p by q, because you have mentioned their length x and y. This one has length x, this one has length y. P by q is simply write x by y. Vector division is not allowed. That in higher mathematics or physics, that will be referred as a tensor quantity. Okay, so we just do it. We just be little bit changing our behavior here. We are dividing but scalarly. That p by q equal to x by y. You can write. So p is equal to x by y into q. P is equal to x by y into q. They have the same direction. So when you have written p equal to x by y into q, that unit vector, it has magnitude. What is the magnitude of unit vector? That is always 1 unit. So if you write p into r cap equal to x by y q into r cap, this implies p vector equal to x by y into q vector. That x by y I am taking m. Let x by y equal to m. So this implies p equal to m into q. This is true for any two parallel vectors. One is the scalar multiplication of the other. Obviously, unit vector magnitude is 1. This I have already told you. If we take modulus of two sides, mod A equal to mod of this thing, mathematically the first session will be mathematical. That is going to be the vector modulus of this left side equal to modulus of right side. This is mod A. On mod, if you apply mod, no effect. This will be 1. So A cap, its magnitude will be A cap. Magnitude of A cap is always 1, and this is advantageous for us. Any vector in a particular direction you can write if unit vector is known. Unit vector is used to assign the direction. That's why for two parallel vectors p equal to m into q. Now this is the time to explain negative of a vector, because we are going to learn addition of two vectors. What is negative of a vector? Let us define negative of a vector. Suppose we have a vector AB over there. This is vector AB. Any vector. R vector we have written as AB. Now, if we want to write BA vector, this is A, this is B, BA direction is changed. So BA vector going to be just direction change, we will put a minus sign before. BA vector will be minus AB. Direction change, minus sign. If there is unit vector along x-axis is I cap, this is I cap, then unit vector along this axis will be minus I cap. This way, if it is j cap, opposite direction the unit vector will be minus j cap. So when I am writing AB vector, suppose it is directed along x-axis, then AB vector is what? AB has magnitude mod AB equal to x. Then AB vector, how can I write? X into I cap. How can I write BA vector? BA vector is negative x-axis. X into minus I cap. So minus x I cap, it will be minus AB. This is the concept of negative of vector. Just you put a minus sign before, then negativity is met. Clear? Negative of a vector. Now we are going to learn addition of two vectors. How to add two vectors. It's very important concept. Addition, you can say subtraction also, but let us understand addition first. Addition of two vectors. We are going to add two vectors. Just why addition is important, let me explain. Why addition is required. Suppose a practical problem we have on this block. We are applying a force towards right, this way. Another force we are writing in this manner. This force be 10 Newton and this one 20 Newton. Force concept you have. This block under the action of these two forces will move in what direction? Will it move along 20 Newton because 20 Newton is larger? Will it move along 10 Newton? This is also possible if you don't specify any rule over there. My answer is it will move neither along 10 Newton nor along 20 Newton. It will move some other direction like this. It will go this manner. Block after some time you will observe that will reach here. Okay, it will reach there. It is under the action of two forces together. But how do I get that direction? And obviously 20 Newton and 10 Newton is not taking the object from O to A. It is the resultant effect. We say that sum of these two vectors will take the object from O to A. This is the concept. Okay. So we have to learn what is the resultant or sum of these two vectors. This addition of vector can appear in many cases. This is just one example I told you. Now I just demonstrate this manner. Imagine a force directed this manner. Another force directed this manner. It can happen. Because I told you vectors can be slid parallel to itself. Here 20 Newton only, we can slid here, we can keep it here. 10 Newton, 20 Newton, we can take this manner also. This is 10 Newton, as it can be slid parallel to itself, we are taking it here, the 20 Newton force. Okay? I'll take it at the tip of 10 Newton. 10 Newton. Then also there is no problem. 20 Newton can go there also. So I am just considering that situation where two vectors are directed this manner. We can slid this one here also. This one you can take here. But we are going to know what is triangle law of addition. This is the fundamental one. All laws can be understood if we know triangle law. Triangle law of addition of two vectors or resultant of two vectors. Triangle law of addition. Addition means subtraction also will be there, you wait. So I have taken two vectors here. One vector is A, the other one B. One vector directed from say O to A, the other one directed from A to B. Let OA equal to A and AB equal to B. We are going to add these two vectors. We are going to add means you have to understand the resultant effect that I am showing you. If I have taken 20 Newton force here, instead of taking 20 Newton, if we slid parallel to itself, 20 Newton, suppose it is taken here, then you see object is moving in this direction. Don't you think that if we complete a triangle, then two vectors are taken along two sides of triangle, third side in opposite direction giving the resultant. So same thing I am going to apply. This is the basic of triangle law. Why people have considered triangle law? This is the reason. Because two things. One, vector can be slid parallel to itself, and second thing is that the resultant we can find along the third side of triangle. This is law. We cannot question over the law. It can be realized with the example. Okay. So direct proof of this is not possible. What is the proof of triangle law? No. This is law. It is based on true observations. This law is universal. I will say eternal also. This law you cannot change. It is always true. So if two vectors A and B are there, then the resultant is given along the third side of the triangle taken in opposite order. So triangle law statement will be like this. If two vectors are taken along two sides of a triangle in magnitude and direction, then the third side taken in opposite direction, then the third side taken in opposite direction will represent the sum of the vectors. So these two vectors OA and OB are taken along two sides of a triangle in magnitude and direction. I mean vectors magnitude A taken along the side OA and B taken along AB. Length of AB is B only. Then OB will represent OA plus AB. This we write by using the symbol R equal to A plus B. Third side in magnitude and direction will represent the sum of the two vectors. So obviously we are interested to know what is the magnitude and direction of the third side. For that, A and B is specified. I mean direction of A and B known. It means angle between them also known. So we are going to find R. It means to find the magnitude and direction here. I am repeating the same diagram here. This is OA, B, OB, vector A, vector B, and this is the third side. It is given that the angle between two vectors is theta. This angle they have given theta. There is a confusion in writing the angle. If two vectors directed this way, then angle between them you can define theta. But if one vector going this way and the other vector terminating here, then this cannot be the angle. What we have to do? We have to produce it forward. The angle between two vectors will be this. This is theta. Keep this in your mind. If two vectors are meeting at the point, then what is the angle between them? Two vectors meeting here, say. Then angle between them you have to find by producing them. Although they are going to be same, but by producing you write. This is theta. So when two vectors are originated from the same point or meeting at a point, then angle is straightforward defined. But one is going away, the other meeting. Then you have to make you have to produce one of them to make them co-initial, because this vector origin and this vector origin is not same. We made them co-initial and then finding the angle between two vectors. So let theta be the angle between two vectors. OA is vector A, OB is vector B. We can write length of OA or mod OA is A, OB is B. We are going to find, sorry, AB, not OB. We have taken AB. AB is B. We are going to find the magnitude and direction of the resultant. This part is AB. Just a minute. So we have to find the magnitude and direction of OB. For that, I'll be drawing a perpendicular on it. On this line, a perpendicular is drawn. This is the perpendicular, BM. Now, in this triangle, in triangle OMB, it is a right angle triangle. OB square, OM square plus MB square. This OB square is OM. OM means what? OM means we are finding magnitude first. That's why I did not take any vector. Definition is this, that R vector is going to be A plus B. But my aim is to find, we are going to find mod R first, length. That's why vector I am not introduced. So OB square will be OA plus AM whole square plus MB square. Let us expand it. So it will be OA square, AM square, twice OA into AM plus MB square. This is going to be OA square plus taking these two things together. AM square plus BM square we are taking together because we will use Pythagoras theorem over there. And we want to express everything in terms of A and B. So here I am writing AM by AB equal to cos theta. So simple trigonometry. AB vector is B cos theta. AM vector, because AB is B, so AM vector is B cos theta. You put it there. OA square is what? A square. AM square plus BM square, in this triangle you can say it is AB square by Pythagoras theorem twice AB cos theta. AB now substitute. It is A square plus B square plus 2AB cos theta. So we got R equal to under root A square plus B square plus 2AB cos theta. Clear? This vector R is A square plus B square plus 2AB cos theta. By putting the values of A and B, we can find, and theta, we can find the resultant. That I will show you. But before that, let us find the direction also. Vector is its magnitude as well as direction. So this direction alpha we need to find. See how to get the value of alpha. Simple trigonometrical consideration we are going to do here to find the value of alpha. I mean, you can say tan alpha also. So for this purpose, we are going to consider the triangle OMB only. Let us consider the triangle in triangle OMB. Tan alpha you can define there. So in triangle OMB, tan alpha is MB divided by OB. MB stands for what? This you can see in diagram. You can write here MB by AB, that we have seen before. No, we have seen AM. So MB by AB, this is actually sin theta. So MB equal to AB sin theta. And this OB in the denominator we can write as OA tan alpha is MB by, sorry, it will be MB by OM. This is not OB. So this you write MB by OM. OM is OA plus AM. Clear? So MB value you put. This is AB sin theta, that divided by OA plus AM. AM is what? AM we have written before. AM is B cos theta. I mean AB cos theta. So at least the value of tan alpha, tangent of this angle we are getting. So tan alpha will be what? AB we know B. It is B sin theta by A plus B cos theta. Clear? So tan alpha is B sin theta by A plus B cos theta. So resultant, I mean length of the resultant vector you got, and you got the angle between two vectors also. Tan alpha you got means you just use your calculator. Tan alpha 1 is coming alpha 45 degree. Tan alpha is coming say 4 by 3, alpha will be 53.1 degree. This all you can find your calculator. I am telling you how to get the angle. You just write it this manner. Alpha equal to whatever result you are getting. Alpha will be tan inverse B sin theta by A plus B cos theta. Alpha is this. So in your calculator you put the shift button, you press the shift button first and then insert this data inside bracket. It will tell you the angle directly. If you don't use calculator, then use trigonometric table. For this one, sometimes you need the concept of square root, or you get it by using calculator. So we'll carry these two formula in future also. But before that, let us learn this triangle law. You keep in your mind. We are going for parallelogram law. Before that, we find what is the maximum value of R and minimum value of R. Maximum and minimum value of R. So in this formula you can see R equal to A square B square 2AB cos theta. R is maximum. This R depend on cos theta. R is maximum when cos theta equal to 1, because cos theta has value lying in between -1 and +1. So R max will be A square plus B square plus 2AB under root A plus B whole square. So R max will be A plus B. Now there is a physical significance of this concept. This cos theta 1 means what? Theta equal to 0 degree, you know. So in case of force vector, suppose I have taken a block here. Force applied 10 Newton and arbitrarily another force 15 Newton. Somebody asked you the question, what is the maximum value of this force acting on the object and what is the minimum value? That is quite obvious. We can use a concept also. If we have applied 10 Newton and 15 Newton in the same direction, then the force will be maximum, and it is supported by this observation that theta equal to 0 degree. So the maximum value in this case will be 10 plus 15, that is 25 Newton. Question is, what is the minimum value? That we do again, that for R the minimum, we have cos theta minus 1, theta equal to 180 degree. Okay, theta is 180 degree. Theta 180 degree, it will be minimum. Our mean will be a square plus b square minus 2ab, that is mod of a minus b. It can be a minus b or b minus a, depend. In this case, if the forces are applied in opposite direction, then resultant will be minimum. 10 Newton we are applying this way, 15 Newton we are applying this way. So resultant force going to be what? 15 minus 10 towards left. 15 will dominate 10 Newton. Resultant force will be acting this way. Clear? Now what will happen if two forces act along two coordinate axes? One force, say 6 Newton acting this way, and 8 Newton. How to find the resultant of these two very first? 8 Newton along y-axis. For that, I am going to modify the formula so that for future you can memorize that. If required, some result, some formula you need to keep in your mind. I will not say that memorize. It comes naturally among you. So, I am going to discuss the case, a special case. Special case already, two special cases are discussed when theta 0 degree and when theta 180 degree. I am going to discuss the case if theta equal to 90 degree. Then what will happen? If theta equal to 90 degree are going to be a square b square 2ab cos 90. So it is simply a square plus b square. Resultant vector is simply under root a square plus b square. And the direction, resultant will act some direction. In what direction it will go? It is very interesting. You will see that it will be more inclined towards the larger force, towards the larger magnitude of vector. This angle will be smaller than this angle. That we will discuss later in problem. Let us write the value of alpha. Tan alpha going to be what? Use the formula for tan alpha in this formula. B sin theta by a plus b cos theta. It is going to be b sin 90 divided by a plus b cos 90. Clear? So tan alpha will be equal to b by a. If angle 90 degree, this is the formula for resultant and this is the formula for angle. Alpha you can write tan inverse b by a. So for this one, total angle is 90 degree. We can see that the angle is 90 degree. This alpha, this is direction of resultant. We pull this formula directly to find the value of r. So answer to find the resultant going to be r equal to a square plus b square, that is root 110. And the angle tan alpha will be just b by a, 8 by 6, 4 by 3. Alpha, use your calculator to write tan inverse 4 by 3. I remember the data always. It is 53 degree or 53.1 degree approx. Some results are there. When you teach, we remember for the next years. So it's like that. Tan alpha, if it is 4 by 3, I remember it is 53 degree, and if it is 3 by 4, it will be 3 by 4. Sorry, that tan alpha 3 by 4, alpha will be 37 degree. Just complementary. Try to keep in your mind. Okay. Now this vector addition we have done purely by using this concept. Let us know how analytically we can find the resultant of two vectors. Okay. For that, we need to know a representation of a vector in 2D. We are going to represent a vector in 2D. So the topic will be that representation of a vector in 2D. I am coming back to that parallelogram law and polygon rule, but before that let me explain representation of a vector in 2D. In 2D, suppose there is a vector given here, just a vector OA equal to A given. We want to represent it in two-dimensional coordinate system. To represent a vector R equal to OA, this is vector R, in 2D, we take x-axis this way. I mean two rectangular axes we are drawing, x and this is y. So what we did, from the tail of the vector we are taking rectangular axis. For what purpose? The purpose is very simple. We wanted to express the vector R equal to OA. How to? See, in two-dimensional coordinate system, every point has a coordinate. So this point also has coordinate. Let it be xy. Draw a perpendicular here. AL. Oh, this doesn't look like perpendicular. So we draw a proper perpendicular. This is perpendicular. Every point has a coordinate. That's why the point coordinate we have taken x comma y. So in this diagram, OM, you can see x and MA equal to y. What have I told earlier? Unit vector along x-axis is I cap and along y-axis it is j cap. This is standard. You never change it. No one changes it. So I cap and j cap. This part is x, this part is y. Now, OM vector you want to write. OM is x, OM vector. It will be what? You just multiply by unit vector. It is XI. We want to write MA vector also. MA going to be y into j cap. OM is XI, MA is YJ. Now go by triangle law. We are going to use triangle law in this triangle. So in triangle OMA, OA vector is OM plus MA vector. OM is what? X into I cap, Y into J cap. Clear? OM plus MA, so XI, YJ. R vector is going to be XI vector plus YJ vector. Any vector in 2D you can represent this manner. So a vector R will be equal to what? Say 2i plus 5j. then 2 is along x-axis, 5 is along y-axis. So here x is along x-axis, y is along y-axis. This x will be referring as component of R along x-axis. X is component of R along x-axis. Y stands for what? Component of R along y-axis. X and Y understood? These are components. What are components? Now, from mathematics to physics, we will take a jump. Why component concept is required? This is very useful concept here. Suppose starting from the origin of two-dimensional coordinate system, an ant goes to this point whose coordinate is 6, 8. I mean 6 meter, 8 meter. This is your x-axis. This is y-axis. So it is quite obvious that displacement is OA vector. That will say displacement is OA vector. But don't you think that we have another way to represent this displacement? What is that way? We draw a perpendicular here. If we say that it is displaced 6 units along x-axis, 8 units along y-axis, it will be appropriate. Instead of saying O to A, the distance will be what? Root over 6 square plus 8 square, 10 unit. So particle going 10 unit in two-dimensional plane, it means it has a displacement along x-axis which is 6. Along y-axis it is 8. It may be different also. But if you take the tip at 6, 8, then all these things quite obvious. You can say that goes from O to A. Equivalent to say that it goes from O to M, then M to A. O to M by 6, M to A by 8. 6 is the component of 10 along x-axis. If this angle is theta, 6 you can write 10 cos theta. 8 you can write 10 sin theta. So these are components. The effective value of a vector along coordinate axis right now, but later on we'll be referring this one as horizontal direction and this is vertical direction. Okay, horizontal component is 10 cos, 6 is 10 cos theta, 8 is 10 sin theta. So in our problem here, this x is component of R along x-axis. If we write this angle as alpha, then we will refer this horizontal component x equal to R cos alpha, y equal to R sin alpha. These are two components. So our concept is clear now. Any vector R has two components, one horizontal one, one vertical one. Component along x-axis, horizontal direction will be R cos theta and vertical direction it will be R sin theta. Now tell me one thing, very easy to state. I am going to ask you particle, suppose I am taking two vectors this manner. We are going to add two vectors analytically without triangle law. So analytical method for addition or subtraction of two vectors. If suppose R1 equal to x1 I cap, y1 j cap, R2 equal to x2 I cap, y2 j cap. If I ask you to write R1 plus R2, how do you do? Mathematically, you will say that I will add coefficients of I. It will be x1 plus x2 I cap, then y1 plus y2 j cap. True, there is no confusion in it. This will be x1 plus x2 I cap plus y1 plus y2 j cap. But the concept lies here. Suppose this is displacement. R1, x1 is along x-axis. For R2, x2 is along x-axis. Net displacement will be what? Sum of these two. Net displacement along y-axis will be what? Sum of these two y components. So adding components is addition of two vectors. This is analytical method of addition of two vectors. Okay. This way we can add two vectors in 2D, two dimension. We can subtract also. We can write R1 minus R2 going to be x1 minus x2 I cap plus y1 minus y2 into j cap. We can subtract these two vectors. What will happen in 3D, three-dimensional coordinate system? Let me explain that also. In 3D coordinate system, we have to take x, y and z coordinates. This is your x, this is say y and this is z. We have done this to represent the vector in 3D. The vector is y. You want to represent it in 3D. So analytically I can show you how this way can be represented in terms of coordinate. In 3D, the coordinate going to be x, y, z. Suppose the vector makes an angle alpha with x-axis, beta with y-axis, gamma with z-axis. Okay. Then this vector, like previous method by using triangle law, applying triangle law twice, we can show that R vector is xi, yj, zk. Okay, this x is component of vector along x-axis. It will be r cos alpha, y will be r sin alpha, r cos beta, these are direction cosines, and z will be r cos gamma. Actually, cos and sin, there is no difference. In case of you have written sin alpha, sin is cos 90 minus alpha. It's like that. But the question is, how can you get this vector presentation in 3D? I'll tell you quickly. Very good concept you will have if you keep the concept of representation in 3D properly. What we do here, we draw a perpendicular here. AM is the perpendicular on XZ plane and join O to M. This way joining. This is perpendicular, means perpendicular to any line in XZ plane. This way joined. Now you draw a perpendicular on x-axis from here. 3D perpendicular, no? 3D perpendicular you should keep in your mind. I have drawn a perpendicular here. On what? On x-axis. So if I draw a perpendicular, this length is going to be x. This length is along this part. This portion is along z-axis. This will be z. And this is along y-axis. This will be y. Clear? So this foot of perpendicular will be L. Now in triangle, OML. OM vector will be what? OM vector will be OL plus LM. What is OL here? XI. We have taken XYZ, so this part is X plus Z into K cap. Unit vector along this I cap. Here J cap and here K cap. And LM vector, OL vector we have written X into I cap. Just a minute. So LM vector going to be what? That LM vector is going, you write OL first. OM is OL plus intertriangle OML. So XI plus ZK, that we have written. But we want to express the vector OA. To represent the vector OA, you consider the triangle OAM. In triangle OMA, OA vector will be OM plus MA. OM vector will be what? X into I cap plus MA vector. It will be along y axis. Unit vector in that direction is J. So R vector will be XI plus YJ plus ZK. Clear? This way you can represent a vector in 2 dimensions. And in this diagram only, I can tell you how the magnitude of this is root over x square plus y square plus z square. See, this angle is 90 degree. What angle? It is perpendicular to any vector in this. So this is a right angle triangle. In triangle OMA, OA square is OM square plus MA square. OM square is OA square is OM square plus MA square. But OM square is what? This is also a right angle triangle. In this diagram, OML also right angle triangle. In triangle OML, OL square plus LM square. So you put it there. MA square. So what do you observe? OL is X, LM is Z, and MA is Y. So OA square going to be equal to X square, Y square, Z square. So length of OA is what? Length of vector OA. This will be under root X square plus Y square plus Z square. That's why I wrote modulus of vector R in 3D is root over X square plus Y square plus Z square. Clear? Now, I'll finish this session by knowing the parallelogram law and the polygon rule. Then vector, what you need to know before starting 2-dimensional motion is done. Let us go back to that portion. And another thing, in 3D also, you can add 2 vectors by adding their x components, by adding their y components, and by adding their z components. Okay? Why parallelogram law or polygon rule I am talking about? Because in some problems, application of triangle law found to be inconvenient. Okay? triangle law is the basic of all the laws. We are going to learn one by one the parallelogram and the polygon rule, but area of application totally different. Let us know parallelogram law first. What is parallelogram law? This time two vectors are represented by two adjacent sides of a parallelogram. These are two sides of a parallelogram, OA and OB. Suppose along OA, this is acting A vector and this is B vector. Then, what is parallelogram law? If they are represented by, if two vectors represented by two adjacent sides of a parallelogram, then you complete the parallelogram. Parallelogram to be completed first. This parallelogram we complete. Then the diagonal of the parallelogram will represent the sum of the two vectors. This diagonal will represent the sum of the two vectors. How? Triangle law we have done different manner. Here different concept. No, concept is same. This vector, if the angle between the two vectors equal to theta, then you slit the vector parallel to itself. Then OB will be coincident with the vector AC. OB will coincident with AC. So this is also B vector. Now in this triangle, OC equal to OA plus AC. So what we are going to learn as parallelogram law, it is just a restatement of triangle law. So let me write the statement. Let two vectors A and B are represented by two adjacent sides of the parallelogram OACB. Okay, we have written where OA equal to A vector and OB equal to B vector. Then by parallelogram law, the diagonal of the parallelogram represent diagonal of the parallelogram passing through their point of intersection, not the other one, passing through their means of those two vectors A and B, the diagonal of the parallelogram passing through their point of intersection represent the sum of the two vectors. Okay, so two vectors A and B represented by two adjacent sides of parallelogram OACB. You complete the parallelogram, then diagonal through their point of intersection, diagonal OC, not AB, will represent the sum of two vectors, and this is actually a restatement of triangle law. This statement is a restatement of the triangle law. Okay, so this time also you can write the formula for R. R is going to be A square plus B square 2AB cos theta, and this angle be alpha. Tan alpha you can write B sin theta by a plus b cos theta, because when you slit this vector, then this one theta means this one also theta. So by these two formulas, the magnitude and direction of R can be determined, same as that of triangle law. But parallelogram law area of application will be different. That we'll see when we are solving problem. Now the other law is polygon rule. What is polygon rule? Polygon rule of addition of many vectors. That's why the concept of polygon is there. What is polygon rule? Let me explain with a few only. I am not taking n-sided polygon in the beginning. This is a polygon A, B, C, D, E, F. Okay. Suppose this one is vector A. This one B, C, D, E. Wait. I did not write F a vector. I am just writing A, B, C, D, E along 5 sides of a hexagon. It may be regular, irregular, it doesn't matter. The polygon rule states that the closing side of the polygon, that is AF taken in opposite sense, will represent the sum of these vectors. This is polygon rule. How? This vector AB and BC you have taken. Let us draw AC vector. AC vector will be what by triangle law? A plus C, A plus B, sorry. A plus B. Then draw AD vector. AD vector is what? AC plus CD. That is A plus B plus C. Then join this. This will be what? A plus B plus C plus D. AE vector will be A plus B plus C plus D. Then AF vector. AF vector in this triangle will be what? AE plus EF. So this is going to be A plus B plus C plus D plus E. We get AF vector. AF vector is R vector. So R is going to be the resultant of these 5 vectors. So we can state the general statement. It is true for septagon, it is true for nanogon, it is true for decagon, duodecagon, whatever you take. We are going to state it for a n-gon, polygon of n sides. For a polygon of n sides, if its sides are taken as, I am not completing the polygon because I don't know the number of sides, how will I complete? Okay. So this vector is R1, say this is R2, this is R3, this is Rn. The closing side taken in opposite manner will represent the sum of these n vectors. R1, R2 or n minus 1 vectors. Because I have taken n-sided polygon. So what will be the statement? For an n-sided polygon, if its sides are represented by vectors R1, R2, n minus 1 sides are represented by vectors R1, R2, Rn minus 1, then closing side of the polygon will represent the sum of the vectors. Okay, this is a very good application. This concept you can use for triangle law, for parallelogram law, for pentagon, whatever you state. Now, a practical question can be solved nicely with the help of this polygon rule. Suppose I have taken few vectors this manner. These are all vectors. Don't take otherwise. These are all vectors. Suppose this is vector A, this is B, C, vector D, E and F. What is the sum of these vectors? I mean, what's the result of A plus B plus C plus D plus E plus F? The answer will be 0. Why? Because if you go by polygon rule step by step, this will be A plus B, this will be A plus B plus C, this will be A plus B plus C plus D. Then this closing side going to be what? O, A, B, C, D, E. OE going to be what? The sum. That is OA plus AB plus BC but OE vector is what? You have taken EO equal to F, so it is minus F. Okay, so this will be changed to A plus B C so sum of these 6 vectors going to be equal to 0. Okay, that's all about vector theory you need to know for your class 11 syllabus. Gradually, we are going to apply the concept of vector in following chapters. Motion in plane, projectile motion is the best example. Relative velocity in 2 dimensions, boats and stream problems. Circular motion, this concept of vector going to be used. Okay.